Hi everyone. I'm making this short video to answer the question raised by one of the participants in my recent presentation with Machine Learning Group, Federal University of Technology, Owerri. She asked, how do you get pixels from an image and how do you multiply it with filters or with kernels? So that's what I'm going to answer here. I will just share my screen. Okay. What I want to do is to write a short code to snap me. That's just to get an image and then use that image to answer the question. I've imported the OpenCV library. It's one of those libraries you will use for, computer vision, image processing, and so on. Of course, you can use a whole lot of other libraries, but I think CV2 is your go-to when it comes to stuff like this. Okay, I'll just create a cap equal to cv2.video capture. So this is to open my default camera on my laptop. Then I can read from it. So search frame is equal to cap.read. And if there is success in the reading, while success, I can show the frames to have some kind of video feedback. So I have cv2.imshow. I can call the window capturing, and it's capturing the frame. Then I can save the images, cv2.imwrite. The file name, so maybe I just call it live pic. And then, okay, let me give a number because I'm running a loop here. Okay, so I give it n.jpg. Let me initialize n here. The idea is to have some kind of live pic 1, live pic 2, and so on. And let me increment the n here. Then I can have cv2.wait key for 1 millisecond to make it very smooth. If this equal to odd of letter Q, so this to allow me to use letter Q to quit if I want to, then I break. So I can, okay, repeat this line to have a loop. Okay, this imwrite, sorry, I need to imwrite a frame. Yeah. Then, if everything is fine, if we break from this loop, we need to release the cap and then destroy all windows. All right. The whole essence of this is just for me to generate a picture, which I would then read the pixel out of it. I can as well copy an image from the internet, but I think you will not need this if you need to get live images for the purpose of training your convolutional neural network. All right, so I'm going to run this. I'm checking if there is a bug. All right, hope everything is fine. Because it's going to use my default camera, I'm going to stop this camera, the one with which you are seeing me now. I'll just stop my video. Okay, so I will be able to run this. Okay, all right, the window is out and it's seeing me right now. Let me bring up a black image so that if I want to make reference to black. All right, so I just press Q. Seen that video ran for a few seconds. So if you check now, I have a whole lot of images here. I don't know, maybe they're up to 3,000 or something, depending on. All right, what I would just do is to read one of the images and then get the pixel out of it. Let me just read 99. I don't know, there must be one bigger than that. There must be one like hard. See 299. This is our range. Okay. Okay. Let me just read. I don't know. I should have done something better than this. Okay, let me just read 499. Let me see if that will do. So I just have IMG equal to CV2 dot imread. Okay, I'm reading the image, and I'm reading the image with name live pic 499 dot jpeg. So if I read this, let me show it here. Plot.show img. All right, so it's not, oh, sorry, it should be im show. Okay, so I'm not reading it here. What's the complaint? It cannot be converted to float. All right. All right, so let me be sure that 499 exists here. Okay, I'm not sure if 499 exists. Let me take 399 instead. Oh, okay, let me just take 365, the one I can see. 365, 365. All right. Okay, so if you see the picture now, it's kind of different from, oh, let me on my video back. It's different from the kind of quality you have here. This is because PyPlot shows BGR while CV2 does BRG or RGB, I mean to say. So if I want to show this correctly, I need to do something like CV2.convert color. Okay, then I need to pass the IMG. Then I need to convert the color now. Color from BGR to RGB. All right, so if you do this, so we have the picture. Now, let's work with this picture. Okay, remember this picture is coming from this image. Okay, so the question is, how do we get pixel out of this? Now, what is a pixel? A pixel, an image is nothing but a collection of pixels. If you take an image like this, and you start dividing into 2, into 4, into 8, into 16, 32, 64, 128, and so on, the smallest unit, which you cannot divide further, is a pixel. Just like you say, an atom is the smallest unit of an element that can exist. Okay, so the same way, the smallest unit of an image is a pixel. A pixel is nothing but color. Okay, if you divide, maybe you have something like 0.26 nanometer, give you a pixel. All right. How do you get pixels out of this? If I just print the IMG variable, if I just print IMG, so these numbers you are seeing here represent the pixels. These are the pixels that make up this image. Take note, it's a three-dimensional array. Maybe you understand it as a list of list. If you check the shape, img.shape, see that it's a three-dimensional array. This represents the height, and this represents the width of the image, and this represents the color channel. Okay, so if you're looking at here, you are seeing 480, 0, 100 to 480, and then from here you are seeing a 640. Okay, so This is a very large number, a large array. If you look at it, there's dot here. It shows that some numbers or some lists are hidden. Okay. Now let's slice this image so that we can pick one pixel and study it further. Let me pick a pixel. Okay, at this point it looked like a white. It looked like white. So let me pick a pixel here. Okay, so let me say 400. Then if you look at it here, let's say I don't know, 150, maybe 170. Okay, let me take 150, 400. That's close to white. So I can have IMG 150, comma 400. So you can see that is 185, 200, 185. This number is between 0 and 255. If you have 255, 255, 255, that will be white. You know, it represents red, RGB, if you are using RGB color model. So it represents RG, sorry, GB. Okay. And normally if you mix 185 red, 200 green, and 185 blue, you will get the color that we are trying to get here. If it is perfect white, you will get 255, 255, 255. If it is perfect black, I was trying to show a black, a cup cover, you know, this black, so that I can show you 000 close to black, but you have to study this long list to get the right image out of it. Okay. Maybe this one will be close to black. Let me try to get this. Let's say this is 600. Let's say this is 200. Or maybe 220, 600. Let me try 220, 600. That should be something close to black. That's close to 000. IMG 220 or 120. Okay, 220, 600. Okay, so not pure black, but you can see it's close to 00. It's closer to 000 than what we have here. So this is a pixel. What is a pixel? It's simply a collection of numbers, and the numbers are representing red, green, blue, RGB. If you are, doing your experiment on the RGB scale, there are other scales, okay, but to keep things simple, let me just leave it with this. So that's simply a pixel. So how do you get a pixel? You read an image. What you are reading is simply a pixel. Is when you are now showing it that you have the image back. Okay, so this is a pixel. Now you see that it's nothing but a matrix, a 3x3 matrix in this case. Now you can slice this matrix and manipulate it. Let me show you what I mean. Okay, let's say I just save this image. What can I do? Let me just try to get the head out of it. If you look at this 0, 100, so my head start from somewhere here. Maybe let's call this one 140 to 140 to, okay, let me to 380, 140 to 380. And then here 250 to 420. So 140 to 380, 140 to 380. And then on the horizontal, like 250 to 420. 250 to 420. All right. Let me call this one head, like my head. Okay. Then if I just show my head now, let me just copy this to show it so as to save time. Then I need to run this. Then let me put this head here. Okay, you can see that I tried to copy the head out of it. Let me increase it. I don't want to cut part of my head off. All right, so this and then this. All right. So you see, I slice out the head portion. This is like cropping, like image cropping. That's what I've done here. Okay, let me manipulate this image that I've cropped. So I can simply do something like this. IMG, let me just equate it to 000. Remember, 000 is black. It's like 0 red, 0 green, 0 blue. So I set this portion to black. Now, if I try to show my image, I'm trying to save time, so let me just copy. If I try to show my image, remember, this head portion, I've equated it to 0, so I've set them to 000. Oh, you can see, I put black there. If I had made this one 255, 255, 255, and run this and then run this. Oh, so I've covered it with white. You know, what I'm doing here is just uh, pixel replacement or pixel substitution. Substituting 255 for every pixel in this range and in this range. All right. So I am manipulating pixels. What is a pixel now? A pixel is the unit of an image. And what is it technically? Is nothing but numbers. And numbers are starting for the how much red, how much green, how much blue you have on it. If you want to get pixel from an image, just read the image. What you are reading is a pixel because an image is a collection of pixels. Simple. So now you see how to get pixel from an image. Read the image like this. And what you read is what you've read are pixels. Okay. What I did earlier on was to open my camera and get pictures. You'll be doing this if you are doing a live, if you are trying to look for images to train your CNN, okay? And you can see that I was able to generate a whole lot of it. Now, the next question you asked, Nkechi, is how do you multiply the image with filters? Okay, it's not pure multiplication per se. It's a mathematical operation, okay? It may be multiplication, it may be finding a maximum, it may be some other thing. But this operation is called convolution. That means you have a matrix here. Now you decide to multiply by another matrix. I don't know. Maybe it may be a 2 by 2 matrix. Okay, so you try to multiply this array or these matrices or list of lists by this new matrix, this 2 by 2 matrix. Now, this 2 by 2 matrix that you are using to multiply it is a kernel or a filter. Remember, I did a manipulation here by doing pixel replacement or pixel substitution. Now, you can use this to do an operation on this. I don't want to just call it multiplication because it's not always multiplication. It could be, like in the case of mass pooling, you are operating this kernel on this matrix or on this pixel array. So there's a way it operates. For example, it depends on the purpose of the operation, the convolution. It may be to find the maximum, like in the case of mass pooling. And it can be a whole lot of operation. So I'm going to record another video. This one is getting too long to show you this kind of convolution or manipulation. So, but the whole purpose of it is that you are multiplying or operating this new matrix on this so as to get something else. It may be to detect edges. like in the case of edge detection, okay? It may be to, to remove color. It may be to turn the color to make the image to have two colors, maybe just black and white. So you may say, for example, any color that is more, okay, 255 is the maximum. You can say any color that is more than 120 should turn to white, and any color that is less than 120 should turn to black, something like that. So if you do that and you operate that on this array, this image will be turned to black and white. So I'm going to record a video for that operation. But I think I've completely answered the first part of your question, which is how do you get pixel out of an image? These are pixels. So multiplying it is not just multiplication, like 2 times 3 is equal to 6. No, it's kind of operation that is called convolution. So convolution operation depend on what you want to achieve, whether you are doing edge detection or you are doing you are turning the image to a grayscale or to a black and white or some other things, or object detection or some other things. So thank you very much. You'll be expecting my other video from this